Today we are going to solve another LeetCode problem, that is LRU cache. It is a really interesting problem and an important one too. So in this problem, we have to design a data structure that follows the constraint of least recently used cache. So what we have to implement here is we have to implement an LRU cache class which contains a get method and a put method. So LRU cache class in which we have a constructor with the capacity. So we have a certain capacity of our cache. We do not have unlimited cache available. Okay, so in the get method, so we'll be given a key and we have to return a value of that key if it exists. Otherwise we have to return -1. And in the put method, we will be given a key and a value. So in this case, either we have to update the value of the key if the key already exists, otherwise we have to add a key value pair to the cache. And the other edge case which we have to handle here is if the number of keys exceeds the capacity, since we have the limited capacity. If say we have a capacity of 3 and our LRU cache already contains 3 elements and we have to add another element, then in that case we have to remove the least recently used key, right? So this is what we have to implement. Let's try to understand better. So say in this problem we are given say capacity as 3, right? Say our capacity is 3 and we have to implement a get method and a put method, and it has been given that we have to implement both of these methods in one time. Okay, so how do, like, first what we have to think about the data structure. What is the best data structure to implement this LRU cache? So the first thing comes to my mind is we have to, like, there are certain points which we have to consider. So we will have to add something like in a key value pair. So I think the first thing comes to my mind is hash map, right? With a key value pair. So I'm thinking of using a hash map. Then I have to add the elements in some data structure in which my get operation will be one time, right? So we can use, say, any array or list to implement the get method. In that way we will get the element in one time, right? And similarly with the put method we can add anything in one, but there is a edge case here. So say when we have to remove an element, when the size of the list is full, then we have to remove the least recently used. So that will take n time. So if we use any list or queue, say, so instead we can use a linked list here. So in linked list we can easily say we can easily remove an element. So if we have, say, we have to remove this node, we can simply set this pointer to this dot next and we can easily remove the element in one time, right? But here we need to, like, once if we have to remove this element, say, then in that case we need to have a reference of this node as well, right? So what we can do is in our hash map, we, instead of having a key value pair of integer type, we can have we can have a key value of integer comma the node reference type. Will store in our hash map the integer and the node, corresponding node to that. So if we have a reference of this key with a node, then we can easily point to the next node, right? Then the other thing is we have to, like, if we have to add an element, it has to add it in the front. Once a new element, say we add a new element, it will always come in the front. And when we say the size is already 3, and when we have to remove the element, it should always be removed from the last position. That has to be the least recently used. So that in that case, I think we should use a doubly linked list instead of singly linked list. So with these pointers we can easily able to manage. So in this problem we have to do some basic setup as well. So like what we can do is we can create two nodes with the head and the tail. Say this is our head and this is our tail. So whenever we have to find an element, what we will do whenever we add an element, we'll always add it in our map. So in our map we will add a key corresponding to that node, right? Say if we are getting something like 1,5 a input method, so we will add it in our map and we will add it in our list as well. So in our map we will add 1,5. The 5 here will be the node, the corresponding node instead of a value. So say we have to add an element. Adding an element will always be at the front, right? So it will be here. Say we have to add a node with the key as 1, value as 5, right? So if I have to add a node with key value 1,5, it will be, so head will be pointing to this node now instead of tail, and this node's previous will be pointing to head, right? So basically what we are doing is head.next we are pointing to the current node, and node dot previous we are pointing to head, right? And likewise, say if we already have say one node here, then we have to point these two as well, right? And say now if we get a get operation, what we can do, we say we are given, we have in a map we have 1,5, 2,6, say 3,9, whatever, and we get a get operation on key say 4. So we will in one time we can check it on a map, do we have a key with the value 4 with the, if it is not, then simply we can return -1. But say if we have a key, say we get a get operation on key is 2. If we get a get operation on key is equals to 2, then in that case, say in our list, which is say head and tail, and we have elements like this 1,5, 2,6 and 3,9, right? So if we have something like this, they are pointing front and back. So if we get a get operation on 2,6, what we have to do is we have to remove that element from here, and since it is now it is used right now, so it will be come at the top because it is used recently, so it will come here. So now our list should look something like this: head 2,6, 1,5 and 3,9, and that is our tail, right? So similarly, say if we have a put operation now, say for 4,8, now we see the size of the list, the capacity is given as 3, and we already have 3 elements in our list. Then in that case we have to remove the last used element, so which is 3,9. so we just have to remove this element, and we have to remove this element, and we have to add a new element, and adding a new element will always be at the front, and removing any element will always be from the last element which was used. So I hope the understanding is better now, but let's code this one out. It will help you to understand more clearly. So like I said, what we will do, we will create a class node here which will have key and value. Similarly, we need 2 pointers which will be pointing to previous and next, so we will have a node previous and node next, and we'll create a constructor of this class as well, public node int key and int value, and this dot key is equals to key, and this dot value will point to value, right? And like I mentioned before, we will create a map with a key of type integer and value of type node. So we'll create a new hash map, and we will create two nodes as well, the head node and the tail node. Everything will be added between the head and the tail. So node head is equals to new node. We will initialize with say 0, 0, or you can initialize with anything like -1. That does not matter. We will just have our head and tail nodes, right? And we will take a capacity as well, so that we can use in other functions here. So first of all, the capacity would be capacity. We can use this dot capacity here, capacity, and we will point the pointers of head and tail to each other. Head dot next will point to tail initially, and tail dot previous will point to head, right? So as of now, we'll have both these head and tail pointers pointing to each other, say like somewhere like this. Say we have a head and tail is pointing to each other right now initially. Okay, we can just comment this one out. So when we get a get operation, first of all, what we're gonna do, we're gonna check if the map already contains this key or not. If map does not contains the key, that would be key, we can return -1. That is pretty simple case. If our map does not have this key, we can return -1. But if our map does contains this key, like I mentioned before, first of all, we have to remove that element from this list wherever it is present, and we have to add that element at the top. So removing the element would be, say we will have a node is equals to map dot get. We'll get the corresponding node for against that key, and we will create, don't worry about this remove method as of now. So like we have to remove that element and we have to add that element at the front. So adding will always be at the beginning, from the front, and removing the element whichever node we have to remove. And once we are done with this operation, that means our map already contains this key, so we can return the current node dot value. Don't worry about this remove and add method. I'm gonna explain it after this. So now move to put operation. Now in put operation, like I mentioned before, if our map already contains this key, in that case we have to remove that node. So why do we have to remove? Because say now map contains 1,4 and we get a key with a 1 but value 5 this time, so we have to remove that key which was already present in the map. So we will remove it wherever it is, and then we will later add that element at the front, right? But there is one more possibility while adding the element, while adding a key value. If the list is full of its capacity, if map dot size, that is our list, is already equals to capacity, so we have to remove the last element. So last, we know we can easily access from the tail, so we will again use this remove method. We will write this helper method add and remove, but here we just have to return tail dot previous. That's why like we have to use a W linked list. Now we can easily remove the last node, right? So, but say in case we do the map does not contains this key, or the it is not out of capacity, either way we have to add that element in our list, right? So what we're gonna do, we're gonna pass this new node with a key comma value, since it is not available now, right? So the other thing which we have to do is we have to write these add and remove method. So first of all, we'll write add method, which will take a node. These are pretty simple methods. So while adding an element, what we have to do, like I said, adding an element will always be at the front, that is at head. So node dot next is equals to head dot next, right? And head dot next, so whatever is the head dot next will point to head dot next dot previous will point to node. Now we have, say, this connection, say this is one node, which is say this is head, and the head is pointing to some node, right? Head is pointing to, say, a old node, and this is pointing to previous node. For better understanding, I just wanna clear things out here, right? Say now if we have to add a new element, say now if we have to add, or I can better explain on an iPad, so it will be easy for you to understand there. Say we are at, this is head, and this is already some node here already present. So what we are gonna do, say old node or anything, and we get a new node here. So what we're gonna do here, so head dot next will so basically first of all we gonna make this operation, that is node dot next is equals to head dot next. So head dot next is pointing to this, node dot next now will point to this, and head dot next dot previous, which is pointing here, will point, which should point to node. So head dot next dot previous should point to node. So basically this link will now point to here. So we do not have this now, and then it is pretty simple. The head is now pointing here, but it should point to this node, and this pointer should point to this node. So head dot next should be node, and node dot previous should point to head. So these are pretty easy 4 points. Now let's write this one out. I hope you are able to understand this one now. So we'll need to do head dot next is equals to node, and node dot previous should point to head, and we will add it in our list as well, or in our map as well. Map node dot key and whatever is the node, right? Now let's write the remove method. So node, so remove method is again pretty simple. Let's try to understand first what we are gonna write there, then it will be easy for you to understand, right? Say we are given we have 3 nodes, say head, and this is some node, and this is say tail. So removing an element will always be from the bottom, or say any node. It will not be always bottom, but say we have to remove this node, right? Say this node, we have this reference of this node and we have to remove. So this is pointing here, this is pointing here, say this is pointing here. Similarly for these as well. So if we have to remove this node, we have the reference of this node. What we have to do is the current node dot next dot previous should point to node dot previous. So node dot previous is this. So what I'm saying here is that node dot next dot previous should point to node dot previous. So basically node dot next is this node, dot previous is this link. This link should point to this node now, not the current node. So that will be node dot previous. Node dot previous is pointing to this one, right? So this will point to this now. So we have successfully made this connection. Now the next node should point to this node, the node dot previous, that is node dot previous dot next. So that is we are talking about this connection, this link. Node dot previous is this node, dot next is this point. It should point to node dot next, which is this one. It should point to node dot next, which is this one. So we will make a connection here. So that's it for the remove method. What happened? Not sure what happened there. It's still safe, so yeah, we can. So node dot next dot previous is equals to node dot previous, and node dot previous dot next is equals to node dot next, and we have to remove it from our map as well. Map dot remove node dot key. Let's try to give it a run, and it is working fine. Let's try to submit this one, and it is getting accepted. I hope you understand the solution. Thank you.